I am Dr. V.S. Madhusuresh, Professor and Head, Department of Mathematics, Rogini College of Engineering and Technology. Course code MA8251, course name Engineering Mathematics 2nd. The course outcome: after completing the course, the student able to modeling the various laws of physics. Here today I am going to teach gradient, directional derivative, angle between two surfaces. Gradient, directional derivative. The vector differential operator del is denoted by del equal to vector I into dou by dou x plus vector j into dou by dou y plus vector k into dou by dou z. Del is denoted as gradient, vector differential operator. Here I vector, j vector, k vector are the unit vector along the three rectangular axes ox, oy and oz respectively. The formula for finding the gradient or del is del equal to vector I into dou by dou x plus vector j into dou by dou y plus vector k into dou by dou z. The gradient of the scalar function. Here phi is a function with variable x, y, z. Phi of x, y, z is a scalar point function continuously differentiable in a given region of space. Then the gradient of phi is defined as del pi. Grade means del, grade pi means del pi, gradient of pi, del pi, that is equal to vector I into dou pi by dou x plus vector j into dou pi by dou y plus vector k into dou pi by dou z. It is also denoted as grade pi. Here pi is given problem. Here pi equal to 3x square y minus y cube z square at the point 1 comma minus 2 comma 1. Here find the gradient of phi. Given pi equal to 3x square y minus y cube z square, grade pi equal to the formula vector I into dou pi by dou x plus vector j into dou pi by dou y plus vector k into dou pi by dou z. First to partially differentiate phi with respect to x, that is dou pi by dou x. Here 3 into the differentiation of x square 2x, that is y is constant 6xy. To partially differentiate phi with respect to y, that is dou pi by dou y 3x square into 1. Here the differentiation of y cube 3y square, that is minus 3y square z square. Then dou pi by dou z. To partially differentiate pi with respect to z, here there is no z term, first 0 minus differentiation of z square 2z, that is minus 2y cube z. Y cube is a constant. First to find dou pi by dou x, dou pi by dou y, dou pi by dou z. Then grade pi, del pi, that is vector I into the value of dou pi by dou x plus vector j into the value of dou pi by dou y plus vector k into dou pi by dou z. Then grade pi at the point, replace x by 1, y by minus 2, z by 1. Then we get grade pi minus 12i vector minus 9j vector plus 16k vector. Another one problem. Here phi is given at the point 2 comma minus 2 comma minus 1. Then find modulus of del pi, modulus of grade pi. Here pi is given. Here del pi equal to formula vector I into dou pi by dou x plus vector j into dou pi by dou y plus vector k into dou pi by dou z. First to partially differentiate phi with respect to x, that is dou pi by dou x 2z power 4 minus 2xy. Then to partially differentiate phi with respect to y, that is dou pi by dou y. Here there is no y term, 0 minus x square into 1 minus x square. Then to partially differentiate phi with respect to z, that is dou pi by dou z 8xz cube. Then del pi equal to vector I into the value of dou pi by dou x plus vector j into the value of dou pi by dou y plus vector k into dou pi by dou z. Then find del pi at the point 2 comma minus 2 comma minus 1. Replace x by 2 and y by minus 2 and z by minus 1. We get del pi at the point equal to 10i vector minus 4j vector minus 16k vector. Then find modulus of del pi. Here if del pi equal to xi vector plus yj vector plus zk vector, modulus of del pi equal to root of x square plus y square plus z square. That is root of the coefficient of I vector the whole square, that is 10 square 100. Then the coefficient of j vector the whole square minus 4 the whole square 16. Then the coefficient of k vector the whole square minus 16 the whole square, that is 256. Therefore, modulus of del pi equal to root of 372. Then next, directional derivative of a scalar point function. The directional derivative of a scalar point function in the direction of a vector is given by directional derivative equal to del pi dot a vector by modulus of a vector. Here a vector is given in the direction of a vector. Then first find del pi. Pi is given, find del pi. Then a vector is in the given vector. Then find modulus of a vector. Then final directional derivative equal to del pi dot a vector by modulus of a vector. Maximum directional derivative. The maximum directional derivative is modulus of del pi or modulus of grade pi. Modulus of del pi or modulus of grade pi. Here the problem, find the directional derivative of phi is given at the point 1, 2, 0 in the direction of a vector. A vector is given. Find also its maximum value. Maximum value means modulus of del pi. Here pi equal to xy plus yz plus zx del pi. Find the directional derivative of pi. Here find del pi, vector I into dou pi by dou x plus vector j into dou pi by dou y plus vector k into dou pi by dou z. Here find dou pi by dou x, dou pi by dou y, dou pi by dou z. Then substitute these values. Del pi equal to vector I into y plus z plus vector j into x plus z, vector k into y plus x. Then del pi at the point 1, 2, 0. That is replace x by 1, y by 2, z by 0. We get 2y vector plus j vector plus 3k vector. Here in the direction of a vector is given. A vector equal to I vector plus 2j vector plus 2k vector. Then find modulus of a vector, that is root of x square plus y square plus z square, 1 square plus 2 square plus 2 square. Therefore, 9, that is equal to 3. Then final solution, directional derivative, del pi dot a vector by modulus of a vector. So del pi equal to 2i vector plus j vector plus 3k vector dot a vector, I vector plus 2j vector plus 2k vector by 3. Then dot product of two vectors, numerator I dot I1, j vector dot j vector 1, k vector dot k vector 1. Therefore, 2 into 1, 2, plus 1 into plus 2, plus 2, plus 3 into plus 2, plus 6 by 3, that is 10 by 3. Here, find also directional derivative answer is 10 by 3. Find also its maximum value means to find modulus of del pi. Here, del pi at the point is 2i vector plus j vector plus 3k vector. Modulus of del pi equal to root of 2 square plus 1 square plus 3 square, that is root 14. Then next question, find the normal derivative to the surface x square y plus xz square at the point. Here normal derivative means find modulus of del pi. Here the surface is given, pi equal to x square y plus xz square. Then find del pi. Del pi means grade pi. Vector I into dou pi by dou x plus vector j into dou pi by dou y plus vector k into dou pi by dou z. First to partially differentiate phi with respect to x, then pi with respect to y, then pi with respect to z. Substitute the values of dou pi by dou x, dou pi by dou y, dou pi by dou z and del pi. We get del pi equal to vector I into 2xy plus z square plus vector j into x square plus vector k into 2xz. Here del pi at the point, replace x by minus 1, y by 1, z by 1. We get minus I vector plus j vector minus 2k vector. Here the question is find the normal derivative. Normal derivative means how to find modulus of del pi. That is root of x square plus y square plus z square minus 1 the whole square plus 1 square plus minus 2 the whole square, that is equal to root 6. Next, very important, angle between the surfaces. Here phi 1 and phi 2 be any two surfaces. Then the angle between the two surfaces is cos theta equal to del pi 1 dot del pi 2 by modulus of del pi 1 into modulus of del pi 2. Pi 1 and pi 2 be any two surfaces at the point is given. The angle between two surfaces pi 1 and pi 2 is theta. Then theta equal to cos inverse del pi 1 dot del pi 2 by modulus of del pi 1 into modulus of del pi 2. angle between two surfaces theta equal to cos inverse a vector dot b vector by modulus of a vector into modulus of b vector. Here next the problem, find the angle between two surfaces. Here two surfaces is given. Take first surface as pi 1. Here pi equal to x square plus y square. Take z as right side, that is minus z minus 3. First surface pi 1. Then find del pi 1. Vector I1 vector I into dou pi 1 by dou x plus vector j into dou pi 1 by dou pi plus vector k into dou pi 1 by dou z. That is vector I into. To partially differentiate pi 1 with respect to x, then to partially differentiate pi 1 with respect to y, then to partially differentiate pi 1 with respect to z, we get del pi 1. Here del pi 1 at the point, replace x by 2, y by minus 1, z by 2. We get 4i vector minus 2j vector minus k vector. Next the second surface is phi 2. Phi 2 equal to x square plus y square plus z square minus 9. To find del pi 2, vector I into dou pi by 2 by dou x, vector j into dou pi 2 by dou y, vector k into dou pi 2 by dou z. To find, to partially differentiate phi 2 with respect to x and phi 2 with respect to y and phi 2 with respect to z, we get the value of dou pi 2 by dou x, dou pi 2 by dou y, dou pi 2 by dou z. Then del pi 2 at the point 2 comma minus 1 comma 2. Replace x by 2, y by minus 1, z by 2. We get 4i vector minus 2j vector plus 4k vector. Then modulus of del pi 2, that is equal to root of x square plus y square plus z square. We get root 36, that is equal to 6. Then final answer. The angle between the two surfaces phi 1 and phi 2 is theta equal to cos inverse del pi 1 dot del pi 2 by modulus of del pi 1 into modulus of del pi 2. Here cos theta equal to del pi 1 value dot del pi 2. 4i vector minus 2j vector minus k vector dot 4i vector minus 2j vector plus 4k vector by modulus of del pi 1 into modulus of del pi 2. That is modulus of del pi 1 means root 21, modulus of del pi 2 equal to 6. Then the final value I vector dot I vector 1, j vector dot j vector 1, k vector dot k vector 1. Therefore we get 16 by root 21 into 6, that is 8 by 3 into root 21. Therefore theta equal to cos inverse 8 by 3 into root 20. Some important questions in this topic. Thank you.